We live? Good morning. Hey, thanks for coming on Thursday morning. I have the enviable position of being before lunch and right before most of your departures, I'm sure. So thank you for showing up. Really appreciate that. My name's Sean McCurdy. I'm the Vice President of Elastic's DoD business. And we're very fortunate to count the Army as one of our largest customers here at Elastic. So for those of you that serve, we appreciate your sacrifice that you and your families make. I'm an Army brat myself, so while I've never served, I was dragged around this beautiful globe of ours many years. So thank you for what you do. Appreciate all that you do for our country. So today we're going to talk about a non-traditional use case for Elastic, right? Most folks know Elastic from cybersecurity. And while we do cybersecurity really well, most people don't realize that our roots are as a search company. So we'll talk a little bit about that. We'll talk a little bit about the innovations that we're bringing into some of the tactical networks and what that looks like in terms of capability sets that you can be using your existing software that you've purchased from Elastic to take care of. So I'll start with the bottom line up front, right? We are an enabling technology. We're a platform that allows you to do many different things with a single tool set. So typically, when we roll out into a new environment, we're replacing 5 to 7 other tools so that you're more effective with a single pane of glass than you would be with lots of other different capabilities. And again, in the DoD, you might not know all the different places that you're using Elastic today, right? We are the engine under the hood of many different data platforms. And in your personal life, you probably use Elastic on a fairly regular basis without even knowing it, right? When you type something into the Amazon search box and you get that predictive response, there's Elastic under the hood that's feeding all that. If you take an Uber, right, the geospatial search that connects you to your driver is Elastic under the hood. If you look on Netflix and you want to look up your favorite movie, that's Elastic that's doing that search. So about 60% of the customers that use Elastic use us only for search. They don't do any cybersecurity work with us. So it's a really powerful tool set that we all interact with, oftentimes without knowing it. So we're going to shed some light on how the Army could be using Elastic inside of the edge capability sets that you're developing. So first and foremost, though, I want to ask the question, right? It's not entirely rhetorical, and for the sake of time, I'll answer the question instead of doing an audience poll, right? Normally, I'd like to make this very interactive, but why do we collect data? We collect data because data is the new oil, right? It is the new currency of the digital domain. So whether that's sensor data, right? That's radar data, it's aircraft tracks, it's OSINT. We want data to be something that we can leverage as a strategic asset. And we want fast, reliable, and interactive access to that, right? One of my favorite things, if anybody out here has used the big data platform, right? It's a big data platform, but it gives you yesterday's answers tomorrow, right? It doesn't give you real-time access to the data that you need. Elastic is all about real-time access, right? Like if the Chinese are in my network, I want to know right now that the Chinese are in my network. I don't want to know in 2 or 3 days when an analytics done running, right? And so that's why we collect data. So in an operational environment, we need to do that on the fly, and we need to do it in a way that gives us reliable and fast access. I won't go through the architecture of all the different challenges of data management, but one of the reasons that's really difficult is that data gets siloed. Right? I love our friends over here at Anduril that are starting to build out the NGC2 platform, right? There's like 8 different data silos inside each one of those boxes, right? We got to break those silos down and provide a single interface for that data so that we can search it, we can scale it, we can make use of it. And Elastic is one of those platforms that has that capability set, right? We have a number of customers in the classified domain that are using Elastic for searching various forms of intelligence, whether that's SIGINT, visual intelligence, geospatial intelligence, audio intelligence, human, right? And so that capability set can live on a very, very small form factor. And that's one of the things we wanted to emphasize today is you don't have to run Elastic in the cloud, right? We have customers in the Army network that are running Elastic on a device about the size of a Raspberry Pi and a soldier's backpack forward deployed, right? So the capabilities that I'm going to describe today don't have to run on a massive, hyperscaler class infrastructure. They can run out on the edge. So when we talk about search, and I want to frame up the question, 2 years ago when we started talking about changing the way people search data, and using large language models as part of that process, using different modalities of search. Most people were still used to the keyword search that we get from Google, right? And we all know our jobs when we're doing keyword search, right? If I want to figure out what the NIST password strength requirements are for a deployment that I'm doing to meet my RMF requirement, I would put in the keywords, hey, NIST password strength, and I'd get 57 different links, and I'd have to sort through them and find the link that was relevant to me. But anybody that does a Google search today on their phone, right, you know that you're getting back an AI summarized version of what's going on, right? And they'll usually have like a little link, and that link is enabled by what we call in the industry retrieval augmented generation, right? And what that means is we're bringing private data into the context of that large language model, right? One of the big misconceptions that we want to dispel is that the only way you can do that is on these massive data sets and in the cloud, right? This is something you can do at the tactical edge, and you can build it relatively easily, and you can build it in ways that are certified, compliant, and you can get your ATO on, right? So that's what we'll talk a little bit more about today. So what we're evolving to is natural language questions, right? Hey, what are the NIST password strength requirements, right? And we expect to get a natural language answer. But what's super important if we're deploying this in an edge environment where we're talking about intelligence in particular, or we're talking about fires, we need to know the answer is reliable, right? Because our job as the user has changed. We've gone from sorting through those 57 different links to now getting a single answer, and we have to understand the veracity of that answer, right? But the brain's chemistry says, if I get one answer, it's got to be right, right? So we need to understand architecturally as technologists that the tools we're putting in a forward deployed environment are something we can trust, right? So the way that works and how Elastic powers that is we can be that data set, that verified and certifiable data set that feeds the large language model. And what we do then is we take this question and we parse it into what we call a vector. And I'm going to talk a little bit about what vectors are because vector databases, vector search is a cool buzzword, but it's kind of abstract and not a lot of people understand it. So we'll go into what that exactly means. But Elastic is a vector database, right? We can take geospatial coordinates, we can take text, we can take images, we can take audio, we can take electronic warfare signatures like waveforms, and we can encode those in a language that the machine can understand, right? Through natural language processing, and then provide that as context to a large language model. We can do all that with privacy mitigations in place, right? So one of the most important things is, even if you're running in an air-gapped environment, you might not want to send every piece of information you've got on a bad guy to the large language model, right? And that might be for speed. It might also be to make sure that we're guaranteeing that asset is not exposed, right? Built into Elastic is the ability to redact PII, to redact things like, a unit's location, right? And we can do all that also based on role-based access control, right? So Specialist Stuffy out at the edge maybe doesn't get to see exactly where a unit is, but he can query, context from them, right? But, Major General up at the division probably should be able to see where that unit is, right? We can do that based on role and redact selectively as well. So a really cool way that search is a mission enabler today that we're starting to roll out to the cyber protection brigades, and that's coming out into the field here in the next 6 to 12 months in the CPB kits. We're showing it over in our booth, is using this technology as part of your security operations center work, right? So instead of an analyst getting 1,000 alerts in their inbox in the morning around a cybersecurity incident, we can take those alerts, we can use the reasoning power of a large language model, and we can filter those through the MITRE ATT&CK framework, your tactics, techniques, and procedures, right? Your standard operating procedures, and we can build a summary of what the attack actually is that the soldier can then interact with in a natural language way and totally correlate that against the MITRE ATT&CK framework, as an example, right? And again, this is not something that you have to do in a cloud-based environment. We're doing that in our booth on a box, just like the boxes your teams deploy, right? So this is a box from our partner Ceiling Tech, not making a brand endorsement by any means, but we got great partners like Dell and NVIDIA, and we got HP and Ceiling Tech and others that'll all be happy to talk to you about what their hardware looks like. We just happen to be showing it in a box like this, right? It's carry-on compliant. This is what the cyber protection brigades roll out, right? They have some bigger ones, they have some smaller ones. The key difference here and the enabler that I would ask y'all to consider as you're thinking about what you forward deploy is this has a nice big beefy GPU in it, right? So we're running a local large language model called Mistral, which is approved by the NSA. It's gone through the AI Security Center up at the fort. It's approved, right? We can run that completely air gapped. And while it's not going to be like instant response like we're all used to from ChatGPT 5 or from Gemini, right? That model, it'll give you very, very good results, right? So we've benchmarked that attack discovery that I was just showing you for AI cyber operations. We can run that in near real time for 5 to 10 users, right? So it is beefy enough that at the edge, we're starting to see these capability sets delivered, right? So I'll pivot and talk a little bit about the underpinnings, because I've talked about what we want to deliver. I'll talk about the how, right? So, and again, you can do this with Elastic. There are other technologies that you can do this with as well. So this is really just an industry perspective on how you can power these types of applications and the things you need your soldiers to start thinking about architecturally as you look at how to drive these capabilities at the edge. So number one, right? Everybody is all hyped on AI, but AI is just a form of machine learning, right? There are different types of machine learning, right? And Elastic supports many different types. We're working with PEO missiles in space, for example, on unsupervised anomaly detection, which means they're constantly looking at the electromagnetic frequencies around a given device, and they're running those through a machine learning job constantly in Elastic to say, hey, you know, if I match a certain pattern or a certain signature, I've got an attack, right? And that's obviously, while it's non-kinetic, it's also not TCP/IP based, right? So just because AI is the buzzword doesn't mean that's the only type of capability set for search that you can deploy at the edge. We're also doing things called supervised machine learning. And that's when we kind of record what's going on the network for an hour, 2 hours, a week, 2 weeks. We're doing that with some very interesting customers at Stratcom, for example, where they have some very old networks, right? You can think about some of those things that have been sitting in the ground for 40 or 50 years, right? And while they're speaking TCP/IP today, they're not speaking any protocols running over that any of us would recognize in the IT world, right? We can still classify those and apply machine learning jobs to make sure that we're detecting anomalies on that very unusual network and that very unusual infrastructure, right? And then lastly, there's natural language processing, and that starts to get into this world of AI, right? So typically what we say is, you got to learn how a system is operating normally, right? Maybe it's a Patriot battery, maybe it's a counter UAS system, right? Think of any of your different fielded devices that might be interesting to learn about and make sure are operating well. Then we can predict and operationalize anomaly detection and the kinds of responses that would say, hey, this is not working the way it should. We can also do this in a geospatial realm, right? So I mentioned you connect to your driver if you take an Uber using Elastic. Well, Army Corps of Engineers is using that same anomaly detection now, and I'll show a picture of this a little bit later in the slides, to monitor all of our nation's waterways. So when there's a rainstorm, they make sure they send the right number of dredges out to make sure that the waterway is clear and the goods and services that we all count on. And by the way, I didn't know this prior to talking to the Corps, 70% of the products that land on your doorstep traverse either a waterway or a port that the Corps of Engineers maintains, right? They get to you coming through, shipping, true shipping, right? And they are using Elastic to monitor the nation's waterways. And what's interesting, again, from an edge perspective, is that capability set they're using can run on that little ceiling tech box that I showed you, right? And they're doing it with LiDAR, they're doing it with satellite, they're doing it in partnership with NOAA, right? And then also handheld scanners and things. And they're fusing all of that data into a picture of what's going on across all of the rivers and coastlines in the United States, using Elastic in a capability set that can be delivered at the edge. And there's a picture, right? So they're taking all of these different modalities and they're actually using the exact same model. It's called H3 that Uber uses to find your driver in order to process these different types of multispectral imaging. So I'll talk a little bit foundationally. I know I'm running short on time, but I think it is of interest to many people. What the heck is a vector? Right? We talk about vector databases, we talk about natural language processing. Kind of cool to understand what's under the hood. And I get very nerdy about this, so I'll try to keep it at a high level. But we can get nerdy afterwards if you want to. So I'm a Star Wars nerd, among other things. So I like to just use Star Wars analogies. So if you think about what a vector is, it is a numerical representation of something that we encounter in our day-to-day life, right? We can vectorize waveforms. We can vectorize images like the Death Star here. We can vectorize text. So when you interact with a large language model, when you're chatting with ChatGPT, you may have heard of this concept called a token, right? A token is a vectored resemblance of a small set of characters, right? Text or an image, now that we're doing multimodal with ChatGPT and Gemini and others, that has been turned into a series of numbers that are representative of where in that database's knowledge, right? That system's knowledge, that concept lives in multidimensional space. And I know that it starts to get very, very like conceptual here, but if you think of, we have 3 dimensions, right? Up, down, left, right, forward, backward, and then we have time, that's 4. ChatGPT uses 1,536 dimensions to represent every set of 4 to 6 characters, every token. And the way those language models work is we feed a huge amount of inputs into them, right? And the reason they're called large language models, we're talking billions of data sets, right? Billions of data points, I should say. And what they're doing is they're then assembling kind of a map in multidimensional space of how every single point in that data set relates to every other one of those billions of points. And that's then this vector, right? So when these models are trained to do image recognition, they're feeding it petabytes and petabytes of image data to understand what this thing looks like. But to break it down and make it a little bit simpler, I'm going to get kind of basic with you, right? So a vector is essentially just a representation in relative space of different concepts, right? So Princess Leia in this image, super realistic, right? Darth Vader, cartoony, right? So if she's a -1 and he's a 1, other different representations, a sketch, a photograph, would fall on this continuum between -1 and 1, right? Well, we can add another dimension to that. Is it human or is it machine? Right? Okay, I got my droid over here, my good friend R2D2. He's realistic and he's a machine. So he's a -1, -1, right? Whereas this Obi-Wan up here is not a machine, but he's also cartoony, right? So I can start to build this set of dimensions where I can group similar concepts together. And this is what large language models do. But it's also what we can do, again, at the edge, using machine learning for images. We can use it for open source intelligence. We can use it for waveforms, right? So when we talk about vectorizing data and making it searchable, this is what we're doing, is we're taking an agreed set of what we call embeddings. We're taking an input and we're turning it into these numerical values, right? So then we can ask questions with unknown data. Where does this guy fit in that vector set? Right? Well, he's pretty realistic and he's definitely, human. We can also start to ask, is he good or evil? Right? And that can be an additional vector. So when you think about, what is vectorization? It's this categorization of concepts that the machine can understand to find similarities that are very arbitrary in terms of what that looks like, right? So an example of a real life scenario, our partner 26 Technologies is doing, and they're doing this with law enforcement. They're doing this with a few DoD entities. They're doing human trafficking prevention using this kind of a service, right? And what they're doing is when they get a warrant and they have the ability to do lawful intercept, they'll start getting CCTV footage of hundreds of cameras in a given area based around where they think those human traffickers are perpetrating their activity. And they can ask questions like, show me every unmarked white van within 2 clicks of this geospatial point, right? And they will search the video feeds to find that. So what we're proposing is, this capability set can be used at the edge in a tactical environment as well, right? You got video sets coming off of a drone. You have OSINT coming off of, say, Telegram feeds, right? We can bring this data into an edge device that's got the appropriate GPU capacity, and we can start asking questions like, show me every video feed you have of a drone hitting a vehicle within 10 clicks of this point, right? And again, what's super cool and why we wanted to have a little chat with you all this morning is this is not like far future stuff. This is stuff that's being delivered today. And this is a capability set you can deliver on the tactical edge with the platforms you're already buying for the cyber protection brigades and at the division and below level, right, from a tactical capability set. So I'll pause there, up on time. I hope this was informative a little bit on kind of what the underlying principles are for search at the tactical edge. And if y'all are interested, please come on by the booth. We can show you this type of service running on a small edge device. Thank you very much for your time.